Hey guys, Mr. Kilburn, and I'm going to do a short video here showing you how to find reference angles with angles that are in radian measure, and even just graphing angles in radian measure. This is where your ability to work with fractions kind of comes to the forefront, and some of you are not big fans of fractions, but they're not going anywhere, so sometimes we just have to deal with them. So let's look at the first example we're going to do here. How about, let's just say 7 pi over 8. Okay, so with respect to the unit circle, you need to remember some basic things like pi is half a rotation, 2 pi is a full rotation, and so on. So if you keep that in the forefront of your mind, then working with fractions becomes kind of not such a heavy lift. And here's what I mean. So if pi is half a rotation, okay, how would I write a fraction with 8 for denominator so that the 8s would cancel and I'm left with just pi? Well, hopefully you're like, well, 8 over 8 cancels, I'm left with just pi, so that would be half a rotation. Okay, well, if 8 pi over 8 is half a rotation, okay, if 8 pi over 8 is half a rotation, then 7 pi over 8 is just pi over 8 before that half rotation. So something like this. Okay, that's 7 pi over 8. Well, if 7 pi over 8 is pi over 8 away from the x-axis, well, then we also get our reference angle. So our reference angle is pi over 8. Okay, let's try another one here. Let's get rid of this, and this, and this, and whoop, not that. Just this. There we go. Okay. How about maybe try one a little more challenging? What about 18 pi over 7? Okay, 18 pi over 7, fine. So again, with that denominator of 7, I know that 7 pi over 7 is half a rotation. All right, so if you want to just break this up into half rotation chunks, maybe that'll help. So we're going to start with our standard rotation with a I just realized I switched those around. That's y and that's x. There you go. So if you were wondering what that was all about, I just found it, so it's Friday, deal with it. Okay, so we always start in the positive x-axis. Now, 18 pi over 7, 7 pi over 7 is half a rotation. So there's 7 pi over 7, which means that 14 pi over 7 would be a full rotation. Okay, so if 7 pi over 7 is half a rotation, so 7 pi over 7 and then another 7 pi over 7, well, half a rotation again would get me 21 pi over 7. But I don't want 21 pi over 7. I just want to go as far as 18. Okay, so I'm going to go somewhere in, rather than full 7, right about in there. Okay, because again, 21 pi over 7 would get me that another halfway around. Okay, so if I went, if 21 pi over 7 would have gotten me another half rotation back down to here, all right, that must mean I'm 3 pi over 7 away from getting to the x-axis. So once again, that is my reference angle. Okay, 3 pi over 7. It's always positive, it's always acute. Okay, let's try one more. I'll get rid of these. All right. Okay, how about 31 pi over, that's not 31, there's 31. 31 pi over, I don't know, 15. Okay. Well, once again, 15 pi over 15 would be half a rotation. So you can almost count by 15s. So starting here, all right, 15 pi over 15, 30 pi over 15, so one full rotation. Okay, so if 30 pi over 15 is one full rotation and I want 31 pi, I just have to go pi over 15 higher, so just a little bit higher. We'll just say it like that. Okay. So if a full rotation again is 30 pi over 15, because that reduces to 2 pi, if that's a full rotation, if 30 pi over 15 is a full rotation, and I want to get to 31 pi over 15, well then I just need to go pi over 15 to get to here. And that's my reference angle. Okay guys, hope that helped. Finding reference angles in terms of radian, even just graphing angles in terms of radians on the coordinate plane. We'll get lots of practice in class, but again, hope that helped. Talk to you soon. Take care. Bye.